Right. So what's cosecant? But you know what? We're now in the world, finally, right? Is this the first time? The first time in forever that we're in a coordinate plane with Trig, correct? It's been real world or whatever. We did talk about sine is so, cosecant's a whole. What? Cosecant's ka, secant's ha, tangent toa, cotangent AO. But when we go in a coordinate plane, your triangles must be like this. It must be. We're going to be talking about coordinate trig now. Remember, I told you the argument for it. It's locations. Earth is in a coordinate plane, latitude and longitude. So it's about locating things relative to each other. So whenever you draw a triangle in a coordinate plane, you don't necessarily have to do this, but you should in many cases. You must draw it like you go to a coordinate. You must go to x, then comma y. So that's x comma y. And then now from here on out, this will be called r. Why? What is this a picture of, everyone? A circle. Then you'll hear something called a unit circle coming up. So that's why hypotenuse turns into r. When you draw your triangle like that, then sine turns into not so. The y coordinate is always the opposite side. And the hypotenuse is now called r because of a radius of a circle that is containing this in a coordinate plane. The adjacent side is always the x coordinate. Look at this. It's always going to be. This is called a reference angle in the future, but that's really the angle alpha or theta prime. That'll be called a reference angle. All right. If you look at that reference angle, the side opposite yet again is the y coordinate. The adjacent side is yet again the x coordinate, and r is now the hypotenuse. So no matter what, the adjacent side will be the x coordinate. And then tangent is y over x. Do we have a pass there? All right, just put it in the middle of my desk. Okay, class that had me last year, it's not so katoa. Whoever had me last year, it's what? Sir, Kixer, Tix. Sir, Kixer, Tix. Not so katoa. You're moving up in the world. All right. It is now called Sir Kixer Tix. Sine is so cosecant to ho. Cosecant is r over y then, the flip of that. So you do go to Sir Kixer Tix, and then you know who the reciprocal brothers or sisters are. However you feel about trig, I couldn't care less. Cosine is ka, secant is ha, so x over r turns into r over x. Tan is tix, cotan is x over y. Let's all say it one more time. Sir, kicks or tix? You're going to have to do this in some questions, but not all. Okay, and then I added these in so to save time, so you don't have to write sine, cosine, tan, and the other three numerous times in here. I did this right before you guys walked in. I put these boxes. You're welcome. Okay. All right. Anyway, so you know what you should do is draw this. Oh, look at how cute this is. Right, but really, what you need to do is understand what quadrant you're in. So I go left 6, up 8, and then you snap back to the origin. By the way, x and y could be negative. R is always positive. Let's put this up here. Okay, let's put this up here. Does it say that? R is always positive. R is just the distance back to the origin. I'm not writing this down. X and Y can be negative depending on what quadrant you're in. It identifies what quadrant you're in. So negative, negative, that means you're in quadrant 3. It's location. It's locations. It's really the only meaning between X and Y being positive and negative. Hey, does anyone know what that hypotenuse is? What is that hypotenuse? It's 10. This is a form of 3, 4, 5. Or I just looked at Mr. Stronowski's class a year ago. They're doing the Pythagorean theorem. They were literally doing that. Then I yelled at them and I go, ooh, in a year you're going to be doing trig just like you're about to do right now. So you're almost a year ago that you did this. Okay, so this is X, this is Y, this is R. All right. and therefore Sir kicks or ticks. So this is 8/10. Okay, fine. You could get rid. You could get away with SOHCAHTOA. Opposite. This is opposite. This is adjacent, and this is hypotenuse. You could survive with SOHCAHTOA and be fine. In the future, in today's notes, you won't be able to survive. You're going to have Sir kicks or ticks in your head. 405. Kixer, X over R, and then ticks, Y over X. Just double checking that I'm not making any mistakes. And then flip them. 5/4, -3, wrong, -5/3, that was my brain, and then -3/4. Okay, so Sir kicks or ticks. You okay over there? All right, next one. What quadrant is -1, -5? Where's that located? So it's -1, -5, and then jump back to the origin. So -1, -5, y equals, x equals. And then what's r? Well, -25 squared is 25. -1 squared is 1. What does this end up becoming? Root 26. I should not have to write the Pythagorean theorem. If you're bamboozled by that, you need to go back to last year. All right, Sir is -5 over root 26, and then rationalizing. Come on, multiply top and bottom by root 26. Sorry, you don't have a lot of room there, but I didn't want to, waste trees. Okay, and then, and some of you guys can well, yeah, I just did that really quick. And then cosines ka, Sir kixer. So that's -root 26 over 26. And then, okay, ticks is easy. Y over x is 5. Right? 5? You good with that? Cotan's easy, 1/5. Do not flip this. Flip this. That's -root 26 over 5. And then flip this. This is -root 26 over 1. I don't think I have to do the third one. What quadrant is the third one in, though? Because I feel like we're going to run out of time. What quadrant's the third one in? Quadrant 4. And you know what? Here's what this is going to be. So I'm not going to do that last. Is that okay? It's more of the same. 2 squared is 4, 4 squared 16, square root of 20. Square root of 20 would be 2 root 5, right? And then you should be able to rationalize and all that other stuff. Okay, but here's the dealio. Look, let's summarize the signs. This is going to be a little acronym. Okay, the little acronym, is that an acronym or no? What's NASA? What's that called? I know what NASA is, but what's that called? It's an acronym. All students take calculus. What? It's a joke. That would be people in my AB. They always do that. All students take, then they okay. So don't try to cancel me. It's just a little joke. All students take, and then we always said calculus. Do they though? But we'll see. Some of you are going to take statistics next year. But it's a little acronym for who's positive, which functions are positive in each quadrant. This is x comma y, right? Who's negative in this quadrant? Who's negative? X. Who deals with x? Kixer. And think about ticks. So what does the S stand for? What does the S stand for? What trig function? Sine and its brother or sister. Who is the brother or sister? Cosecant. So you got to remember who's tied to each other with this acronym. And then in this quadrant, isn't it -x, -y? What's a negative over a negative? So what does T stand for? Tangent. That's who's positive in quadrant 3. Oh, and who else? Nobody. I need my Cricket app. Who else? Oh, it'll take too long. Ooh, how are the stocks doing? All right. Where'd my Cricket app go? Okay, there it is. I got it ready for the next time I ask a question, and it's just like, All right, there are students in here. Isn't y negative here? So who deals with x and r only? Cosine. And who else? Secant. You got to know who the brother or sister is. Okay? If I would have done this one, these would have been positive and these would have been negative. Why? Because those coordinates are in quadrant 4, right? 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 Okay, and that's the whole point of this. So that's a discount double check. And actually, that's how you do these right here. So I'm going to do an ASTC chart here. Everyone okay? There's some whispering out there. Hey, by the way, what's yellow and blue make? So where is sine this? What does that mean they're saying about sine? They're what? They're negative. Where's sine negative then? What quadrants? 3 and 4. So there we go. What did I say yellow and blue make? Green. And then what is this saying about cosine? Cosine's what? Positive. Where's cosine positive? 1 and 4. Where do both happen? 4. Theta has to be in quadrant 4. Isn't that fun? Colors in math. Apologize if you are colorblind. I know that's a thing. All right. So, but this is the best I can do. All right. And then let's go ASTC over here since I don't have to scroll over here. ASTC and do the color game. Do I have to do all of these? No, not really. Okay. Where's tangent? Where's tangent? What is it saying about tangent? Tangent's what? Where's tangent negative? What quadrants? 2 and where? 4. So what we're saying is if I tan an angle measure in quadrant 2, the fraction will be negative, the relationship of the sides. Okay, so I don't want to go too fast on what we're saying here. And then where's cosine positive yet again? Where's cosine positive? 1 and 4. What do blue and yellow make? Green. And yet again, this is quadrant 4. Let's do a secant and a sine. So let's do this one, even though these don't take too long. ASTC. And by the way, this is 100% anyone? Review. Okay, but it's been a while. All right, and this maybe might not have been your favorite thing last year. Where is secant negative? That's what that says. Where's secant negative? 2 and 3. Because secant's related to cosine where they're positive in 1 and 4. Okay, where's sine positive? 1 and 2. So this is positive in 1 and 2. What's the answer then? Theta in this case would have to be in 2 for that to hold true. The last one, tan's positive in 1 and 3. Cosine's positive in 1 and 4. The answer is 1 for this one. Okay, without drawing it out. Has to be. Sometimes there's an overlap and it could be a couple of them. I don't know why we gave a lot of space for this one. But here we go. It's the same. This is really the same thing. This is really the same question as these. It really is. It's just done in a different way. But you have to know circics or ticks in this, but not really. You could get away with SOHCAHTOA and just graph it. But you got to read. What quadrant are we in? What quadrant are we in? 4. So to draw this, you'd have to go 3 wrong. I got to make sure. What is 3 over 5 then? What letters are those? So I have to get X, Y, and R. Maybe this is another way of doing this. What do I know? What is 3, X, Y, or R? It's X. Okay, so it is 3. And then what's 5 then? Y or R, sorry. Be careful of this. So this is 5 here. So then what's Y? It's actually -4 because this is coordinate trig. It's where the terminal side passes through. The terminal side passes through 3 comma. Where did we get -4? This is a perfect little Pythagorean triple. Couldn't think of my words there. X equals R equals. All right. So what sign? Sir. It's -4 over 5. Or, okay, fine. You could call this the opposite side, but you have to know something about reference angles. This is the reference angle. That's like the angle I'm using SOHCAHTOA for. If you want to go to SOHCAHTOA, you're okay. You cannot in the future. All right. And then this is 3 over 5. And then this is, we had these ratios already, didn't we? Negative 4/3. Thought I heard my door jiggle in there. You got to jiggle it. And then 5 over 3. That's an old SNL, George W.H. Bush. Never mind. Like the 1990s. You guys weren't even alive. When were you born? 2000 what? 2007? 2008? Oh, am I so old? And all right, what sign? What letters are these? What letters are these? What over what? That's y over r. So who's negative? Who's negative? Y or r? Y. Because y, r is, say it's, r is always positive. X and y are negative just to locate what quadrant you're in. Okay, what quadrant are we in? What quadrant is this? What quadrant is pi to 3 pi over 2? Which one is that? Which is between pi and 3 pi over 2? Okay, yeah, we're going to actually kind of get you on this. Where's pi? Oh, come on, where's pi? X-axis, y-axis? Left, right? Left, and then where's 3 pi over 2? Up, down? Down. So where's from pi to 3 pi over 2? What quadrant are we talking about? Third. That's my noise for drawing. Negative 2 and then 3. What's x then? What's x become? Root 5. Okay, do you hear how fast they are? Because 3 squared is 9, negative 2 squared is 4, 9 minus 4 is 5, root. But what is x if I go left? What kind of root 5 is it? Negative. I really don't want to do the Pythagorean theorem because you guys should know how to do the Pythagorean theorem fast. It should be x squared plus negative 2 squared equals 9 squared, or 3 squared, which is 9. Subtract square root, but then you have to choose the negative because of this idea that I'm in quadrant 3. When I draw it, then I see that that is negative. Then I can play circix or ticks. All right, and I probably will do that last one because I feel like I am going faster than I thought I might. Sine is negative 2/3. That's nice. Was that the given? Okay, so just rewrite the given. Who cares? The directions do say find all the other 5 trig functions. So this is easy. This is negative 3/2. That's simple. Okay, then the others have radicals, not as much. So this is negative root 5 over 3. And then if you can do this, this is negative 3 over root 5, which is negative 3 root 5 over 5. Can anyone do that? Can you do that? Can you like figure that out? You can visualize negative 3 over root 5 and then rationalize. I hope so. And then tan is the bad one. Tan is the bad one. It's 2 over root 5. Hey, and by the way, all students take tangents positive. There you go. And then I just went against what I just said. Hey, can you do that? Okay, this time we'll go ahead and show it and then do 2 root 5 over 5. Do not flip the second one, flip the first one. It's root 5 over 2, very simple. Okay? So this is just, you're not even finding the angle measures, you're just finding the trig of the angle measures from a particular coordinate. Well, from a particular given trig function, which makes me find the coordinate or missing values. All right, and then this one, this is why I want to do this one, 3 over, 3 over, 3 over, 3 over. See? You should get this app. When your friend tells a joke and no one laughs, hurry up and pull this, like, then just look at your friends. All right, anyway. Very important app. It's my most important app on my phone. 3 over 1. No TikTok. It's going to be canceled. They better not cancel the Cricket app. Oh, I'll be devastated. All right. What is cosecant? Cosecant's a what? Oh, okay. So it's sines flip. What sine? Sine is sir. So this means this is r over y, right? Sine is sir. So this is what I do. This is what I do in my, I think. Sine is sir. So cosecant is r over y. All right? It's the flip of that. I do this, then I go like this. Okay, so then it's the flip of that. It's r over y, not y over r. Sine is sir, cosecant's the flip of that, so it's r over y. Oh, and then what does this mean? Where do you have, this is what this means. Where is cosecant positive, but then apparently cotangent negative? What would that be? What quadrant would that be? It'd be the second. So you got to put that information together because, hey, here's 1, here's 3, and that's my y coordinate, and that's my r coordinate. That looks good. Yes, I'd have to go up 1, but cotangent being negative, that means x has to be negative. All right, fine. It's x squared plus 1 squared equals 3 squared, which is 9. This is x squared equals 8. This is x equals root 8. What is root 8? 2 root 2. So I'll put this here. And then which one? And it is plus minus when you square root, but it's the minus because I went left. All right? So putting all that information, and then do I have to fill this out? You get it from here, right? Okay, rationalizing, reducing, whatever. The point of me being here is make sure you get this information correctly to choose the right quadrants and choose the right sign on the x. Right? Right. Okay, now we're talking here. I did a whole thing of deriving these things 45, 45, 90s and 30, 60, 90s with my class last year. This is what I did. You feel free to put this somewhere or put it nowhere. I couldn't. But what I did last year is I drew an equilateral triangle and I've made all the sides 2, 2, and 2. Remember this last year? My silly little friends that I had? Then I dropped an altitude. Oh, by the way, what are all these angle measures? These are 60, but I'm going to wait on that top one because what does that altitude do? It cuts it in half. So now I have a nifty little 30, 60, 90. What does it do to this opposite side? Bisects. That took too long and needed the Cricut app. Okay, so that's a 1. And then you know what I did with the students? I did the Pythagorean theorem. What's 2 squared? 4. What's 1 squared? What's 4 minus 1? And then what's the square root of 3? The square root of 3. Then you know what I did with the students? I changed this to 12. What does that make this side? What did that make this side? It made it 6 root 3. We actually did the Pythagorean theorem and we got 6 root 3. Then you know what I did with the students? I made it 112. I didn't go that far. But it doesn't matter. If this is 112, that's 112. What's this one? That's a little tougher. That's 56. You know what this ended up becoming? 56 root 3. We could do the Pythagorean theorem and it would work. So you know what we called this letter? We called that A. This became what then? A root 3. And this became what? Doesn't matter what numbers I pick. This happens all the time. That's because every 30, 60, 90 triangle is similar and has similar ratios. And the similar ratios are A root 3, 2A. You lock it in your brain. Next. Yeehaw! I can't remember what I did with the other one. I think I did this. You know, we had a 45, 45, 90. And I think I made this side just 1 and 1. Why? Because it's isosceles. So if one side's 1, the other side's 1. What's 1 squared plus 1 squared? 2. What's the square root of 2? Root 2. And then you know what we did next? We made this 6. What does this become then? 6. What's 6 squared plus 6 squared? 72. 72 is 2 times 36. What's the square root of 36? 6 root 2. Then the next thing I did is I made these 16. What did this become then? 16 root 2. A, that's right. A a root 2. Every single time. It doesn't matter what these two are. This will be whatever that is times the square root of 2. Yeehaw! All right. So how do I do this then? How do I do all the trig function? Oh, I should have put pi over 6 in all of those. Darn it. All right. Missed opportunity. Well, you could go to the coordinate plane. Pi over 6 is actually the 30 in quadrant 1. So I am going to put 30 degrees there because I want you to compare this to, I am going to say this all year long. 25 pi over 6, that's a 30 because it's an over 6. Then I just got to find out what quadrant it is. And then my escape would be to label these sides. Like, what do we make the side opposite 30? 1. What's the side opposite 60 then? 1 root 3. And then what's the side opposite the 90? 2. A root 3, 2a. All right, and then guess what? This is Sir Kicks or Ticks again. This is x, this is y, this is r, because this is a coordinate. This is root 3, comma 1. So this is the beginning stages of this. Then after a while, you're going to have these memorized. Some people do the fingers. I don't know how to do the fingers. Does anyone have the finger trick? Like, no. Like this is 90. I don't know how to do it. Maybe I'll come back to you on that. Many of the teachers use that. I didn't. I just said forced memorization. So sine is so sine of a 30 is a half. Cosine is root 3. Remember these ratios? Root 3 over 2. Remember this? Remember this? And then tan of a 30 is 1 over root 3, which is root 3 over 3. And then flip that. That's 2. Flip that. That's 2 root 3 over 3. And then flip 1 over root 3. That's root 3 over 1. Remember these ratios? Aren't they fun? And then what's the difference with 60? I don't know if the other two teachers are doing this. Couldn't anyone? Care less. I am going to stick 60 in there, which is equivalent to pi over 3. And I will tell you that if I have 25 pi over 3, that's a 60. I just got to find out where it lands, and we're going to work on that later. Okay? So that's all that it is. But wait a minute. What's the side opposite 30? What's the side opposite 30? What number? 1. What's the side opposite 60? 1 root 3. What's the side opposite 90? This is not a unit circle, by the way. When we make this a unit circle, we'll turn that into 1, a radius of 1. That just means you divide all the sides by 2. And then you proportionally divide them by 2. Then this side would be root 3 over 2, and this side would be a half, and then you get your ratios right away. So that's where we're coming to here. All it does is flip-flop that. And then this is root 3. It flip-flops. It's these switch. Okay, well, these switch. These two switched. So this one's root 3 over 3. And then this is 2. And then this is 2 root 3 over 3. You remember these ratios? Aren't you glad that I put these boxes in there? So you didn't have to write sine, cosine, tan, secant, cosecant, cotan. I don't know how many times at this point. Quite a bit, right? And then 45 is in quadrant 1. What are we going to make those sides for 45? 45. 1, 1, 1, what? Root 2. I don't get it. There's nothing to get. I just proved it. I just did the 2, 2, 2 equilateral triangle. And then I did the 45, 45, 90. It doesn't have to be 1. It could be 7. 7, 7, 7 root 2. What's 7 over 7? You still get 1 for tan. Through reduction. You would still get 1 over root 2 for sine, which is root 2 over 2. And then this is root 2 over 2. And then flip this, not the root 2 over 2. Come on. All right? These are the ratios that you were asked last year. All of you were asked this in degrees. So you had questions like, what's the sine of 225? You had to go to quadrant 3. 225 is a 45. And then both the ones are negative. My class, I did go to radians. I don't know if I tested you on radians or not. I might have acquiesced with the other teachers and said, fine, I'll just do degrees. And then radians will be next year. Okay, then these are called the quadrantals. This is where you're doomed if you don't accept Sir Kixer ticks. The Fadermact, I would write that at the top of a test. Like you last year, you might have wrote SOHCAHTOA at the top of your test to take the Trig test or quiz. The three of them, two of them had SOHCAHTOA in it. So I would write that because this one is a must because these are not even triangles. SOHCAHTOA doesn't work. Where's 0 degrees? Up, down, right, left. Where do I mark a terminal side for that? Right. So this is actually just this point right here. Interesting. I have an infinite amount of points I could pick that this side goes through. What might be the smartest, easiest point? I go right, and I don't go up and down. What would be a point, everyone? 1, 0. This is why I choose this because it's simple. I could pick 23, 0, Michael Jordan, right? But then why would I do that? And if I pick 23, 0, what would R be? Which is just the distance from here to here. If I pick 23, 0, what would R be? 23. But I picked 1, 0, so what's R equal to? 1. There's no triangle here. There's no SOHCAHTOA. There is only Sir Kixer ticks. So what's 0 over 1? This always kills me. What's 0 over 1? 0. But what's 1 over 0? That's undies. And you get undefined now in Trig. Sorry how small that is in there. And are you still on the second page of the 2 on one side? Oh, you're on the third? Very big? Oh, look at you guys. All right. And then cosines 1 over 1. Yep. Safety hazard. If you walked around, if you crinkle your eyes like that, they may stay like that, Okay, so you better be careful. Right? And then tangent is TOA or ticks. So that's 0 over 1. What's 0 over 1 again? What's 0 over 1? 0. So what's cotan? 1 over 0, which is what, everyone? Undies. Okay, that's undefined. Got it? Okay, and I don't know if I had to do all these. What time is it up there? We're doing pretty good. I don't know why. Mr. Gray said they took a long time. I wonder if I missed the formative. Okay. All right. So here we go. Do you want to do a formative? Where's 90 degrees? Oh, sorry. Up, down, right, left. Up. What's that coordinate? 0, 1. Not just 1. And then R equals 1. And then label them X, Y, R. So what's sine? 1 over 1. 1. Cosecant's 1. What's cosine? Kixer. 0 over 1. 1 over 0 is undefined. You should be able to get this now. What's tangent? Oh no, tan is y over x, which is 1 over 0. That's undies. So 0 over 1 is 0. So in these are called quadrantals. When you land, let's put that word up here. These are all quadrantal angles. When you land on, you're not in a or quadrant, sorry, too many words. You're on an axis. These are quadrantal angles. And they have their own special trig for them. All right? Quadrantal angle section. Because where's what 180? Up, down, right, left. Up, down, right, left. Left is what we're saying. So what we're saying, the terminology is here's 180 degrees, which is the same thing as pi. You need a terminal side that goes through a coordinate. So this is the terminal side where 180 degrees terminates. So I need that coordinate, a coordinate, any one. What would be one of them? What would be one of them? -1, comma 0, and R is always equal to 1 in these cases. That's X, that's Y. It's really the same question as the first one, except I get negatives now. That's 0. Okay, so Y over X is still 0 over -1. But then sine is 0, so 0 over 1. 1 over 0 is undefined. This is -1. And then cotangent is x over y, which is -1 over 0. That one I'll write. That's undefined. So notice you don't get 4 negatives like in these quadrantal cases, but you do get some undefineds, at least 2 of them. Not at least, there's exactly 2 undefineds in our 6 trig functions when you're on a quadrantal. Because there's 2 times you're going to divide by 0. Then, of course, where's 270? Up, down, right, left. Up, down, right, left. Down. So the idea is this is 3 pi over 2, and it terminates here. So this is the terminal side, the second side that creates the angle measure. I need a coordinate. What is that coordinate? 0, comma, -1. It's not hard, and this is your discount double. This is your escape if you don't have it memorized. Just real quick, draw it, grab the coordinate, and then label the coordinate. Sir kicks or ticks. This is your save if you don't memorize. Y over x is -1. It's really the same as this, except the first 2 are negative. Because you still get 0 over 1, which is 0, but then you get 1 over 0, which is undefined. You still get -1 over 0, which is undefined, and then 0 over -1, which is 0. So it's the same as this chart, except this one's up top, this one's on the bottom with negatives. Okay, and then the same thing with this. These charts are almost identical, except one is to the left and one is to the right. The one on the left has a negative coordinate. It's really not that bad, is it? No, I mean, it isn't. Like I said, you can always draw this. I'm going to force my A-Bers to draw triangles until they get it. All right. But we'll see if it works. Where does 7 pi land? Where does 7 pi land? I'm going to be honest. It's either up, down, right, or left. It's on the far left. Here's the actual action of 7 pi. 2 pi, 4 pi, 6 pi, and then 6 pi. I got to grow up. 7 pi. So this is 2 pi times 3 plus another pi. So 3 rotations and then another half. All right. What's that coordinate, everybody, if I don't know what I'm doing? What's that coordinate that this passes through? -1, 0, and r equals 1. What's cosine? Sir, Kixer, ticks. What's cosine of 7 pi then? What's the answer? Man, we got a whole bunch of different answers. What's Kixer say? What number over what number? -1 over 1, which is what? -1. The answer to this question is -1. Okay, what time is it now? Good. Where does -3 pi over 2 land? Up, down, right, or left? It is actually up. -3 pi over 2 is -pi over 2, -2 pi over 2, -3 pi over 2. Okay, we're going to speed this up because if you don't get it at this point, you're severely and totally. Anyone? Hey, by the way, who's secant related to? I do this. I write it underneath. Who's secant related to? I write Kixer underneath it then. And then I go like this. This means I have r over x. Sir, Kixer ticks. Say it over and over and over again in your brain because you need to on this one. You need to on these to get this. Sir kicks. So r over x. Oh no. What's 1 over 0, everyone? This is undies. And that's the answer to that question. Do I have to do 6? Where does 6 pi land? Up, down, right, left. Right. Let's speed this up. 1, 0, r equals 1. What's cosecant? Who are they related to? Sir, sine, and it's r over y. R over, are you kidding me? What's r over y? Undies again. I feel betrayed when it's the underwear. Sorry, undefined. Oh, long day, long week. What day is this Tuesday only? What are you putting your stuff away for? What's going on here? We have 7 minutes. Okay. Where's 9 pi over 2 land? Up, down, right, or left? Let's see if you can get it in 3, 2, 1, go. Oh, first of all, an over 2 is definitely up or down, right? You got that? What's 8 pi over 2, everyone? What's 8 pi over 2? 4 pi, right? So isn't that pi over 2 left over? So 4 pi, this is 1 revolution, then 2 revolutions, and then a pi over 2 left over. Who set up initially?
No, you said
Okay. Okay. So therefore it is 0, 1. R equals 1. What's cotangent? Oh my gosh. Oh no, okay, we're good. What's cotangent? What letter over what letter? Who's cotangent related to? Tangent. So you put tix, but then you flip it. So what's cotangent? 0. I was waiting for someone to say the answer 0. Okay, so remember when you tan an angle, you get a ratio of sides. That's the overall, that's why we're getting these numbers here. All right, and then the last ones, I don't know if I have to do them all. I'll pick and choose. Okay, look at your chart on the previous page. What's sine of 30? It's 1/2. What's cosine of 45? Root 2 over 2. And then I don't know what I could do about this. Maybe this? I'm not really sure. You okay? Who said what? Is that you? Is that you? Someone goes, what? Well, this one's good. What's tan of 45? I don't know. So guess what? You could even do this. 1 root 2 and then put 45 right here. What's tan? 1. And then what's cosine of 30? You could do this real quick. Yoink, 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 30. 1 root 3, 2. And then cosine is adjacent over hypotenuse. What's 1 times root 3 over 2? I don't know. You're just doing a combination of two things and evaluating. Okay? What's cosecant? Uh-oh. What's pi over 3? What kind of angle measure is that? It's a 60 degree reference angle. 60. I'm not even doing a coordinate plane because this is in quadrant 1. Fine, I will do a coordinate plane. It's in quadrant 1. There. Okay? What's 60? What's the side opposite 60? Root 3. What's the side opposite to 30? 1. What's the side opposite to 90? This isn't stage 1. After you do this over and over again, we got to come up with tricks. And I'm eventually going to make this a unit circle. So this is going to be 1. This is going to be root 3 over 2. And this is going to be 1/2. I'm actually going to do that. You can do it right now. And then what's cosecant related to? Sine. So it's r over y. R1 over y root 3 over 2, which unfortunately is 2 root 3 over 3. But then I have to multiply that by 3 because I have that out there. See that? So now you have to actually do some evaluating. And then what's an over 4? What's an over 4? 45. So it's a 45, 1 root 2. But you know what we're going to do? We're going to divide by root 2 eventually. What is 1 over root 2? Root 2 over 2. But what's cotangent? Cotangent is x over y, same thing over same thing, which is 1. Okay? So we should remember tan and cotan of 45 is 1. That's super fast. Tan of 30 is root 3 over 3. Tan of 60 is root 3. You can remember those things, then you can know cotan pretty easily. It's the flip of those. And then 1/2 and root 3 over 2 are our tan things. These cancel. This ends up being 2 root 3 plus 1, and there's nothing you can do with that except get a decimal. Is that good enough? Apparently. Now we're putting our stuff away. Are you okay? Oh my gosh. Did I collect your homework? No?